This is a final test of 38436, and we do this on all non-local customers. We do this to make sure that we haven't overlooked anything, so if you see something that is out of not within your expectations, please let us know. And we also do this to show that if it's UPS and they destroy it, that it left here functioning. We're going to connect this up to a pair of speakers as you would at home, but we're also going to connect this up to a test panel where we can make some more critical observations than just listening. This microphone will distort over a certain amplitude, so as we increase the amplitude, we're going to switch from speakers to a dummy load. The dummy load stresses the amplifier the same as speakers, but instead of taking the energy and creating it into sound waves, it takes the energy and creates it into heat. Again, it stresses the amplifier the same. It just doesn't destroy our eardrums or our bench speakers. And what we're going to do is introduce you to the test equipment. Above the amplifier is a dual trace oscilloscope. The upper display will show your left channel, lower display right. Above that, above the frequency counter, this device right here is a pretty versatile instrument. The upper display on that will be your left channel, lower display right. On that, we're going to be able to measure power output and relative amplitude when we do a frequency response check. Okay, let's back this out. There we go, that's good. And this amplifier, like most amplifiers, employs a turn-on delay. So when we turn it on, the amplifier is going to be in protection mode for approximately 10 seconds. That is done to allow the output stages to bias up correctly. If they did not, your speakers would be damaged. And so it's done to stabilize the amplifier before connecting speakers. So let's make sure we have our speakers on. There we go. So we're going to turn it on. And here's our 1001, 1002, 1003, 1004, 1005, 1006, 1007. There we go. It's about a 7 or 8 second delay. It stopped flashing. We're going to turn this up. And again, the microphone may distort from the amplitude coming out of the speakers. And I want to change something here. There we go. The upper display is your left, lower is right. I'm going to go to the balance control. I'm going to go to the right side. You'll see the upper display left disappear. We're going to take the balance control, put it back in the center. We're going to now go to the left side. The bottom display, right channel disappears. Now, as I walk this up in amplitude, it's going to get louder, so we're going to go to the dummy loads right now. And we're going to keep walking this up, and I'm going to change the gain here. So right now we are at, let's take a look at where we are. We are at, about 2 watts. That's 5 watts. That's 10 watts. That's 20 watts. That's 50 watts. And right there is 100 watts. Both channels are clipping. Right at that level, we would hear distortion and we would damage the amplifier if we played it much longer. I'm going to bring this down to about there, which reads 0 dB on the audio analyzer. What we're going to do is do a frequency response test. This item should be approximately flat. In other words, the frequency response should not change when we have all our tone controls set for center. And it should be flat across the audio spectrum, plus or minus a decibel or two. So right now we are feeding 400 hertz in there. I'm going to take the audio analyzer, and what we're going to do is take a look at those horizontal bars, because they're going to measure changes in decibels. Let's see if I can get a better shot here. There we go. what's going to happen is we change frequency, the oscilloscope pattern is going to change. At the higher frequencies, it's going to be a solid bar. So we're going to go down. We're at 400 hertz now, and note at the number of decibels on this display. It's hard to read because this camera has digital zoom, which makes it pixelized. But as we change this, we're going to go down to 20 hertz. There's 20 hertz. You notice still, whoops, come back here, camera. The display is still at 0 dB. Maybe I can do this without hitting the camera. So we're going to walk this up. We're going to go back. There's where we were previous at 400 hertz. Now we're going to go up to, there's 4,000 hertz. Then we're going to go all the way to 20,000 hertz. Now, I don't pretend that I can hear 20,000 hertz. My dog might be able to in a neighborhood bath. But the item is flat across the entire audio spectrum, which is pretty much how it should be. We'll go back down to where we started at 400 hertz. And that will be the end of our demonstration. This item is once again a beautiful performing amplifier. Let's back this out. End this demonstration and send this up to the internet.